Hello, myself Amit Kumar Patel. Today we are going to discuss differential equation. So basically here we'll be discussing a subtopic of this chapter, that is linear differential equation. This is one important topic here. So here we can get two type of things. Okay, first we can have like this dy by dx plus py equal to q. So the condition is that like this p and q should be the function of x or constants. This is required. Okay, so now here's first we'll have to find p and q from given equation. We'll have to compare from here, and then we'll be finding out integrating factor, that will be e to the power integral over p. P is what? P, either it will be constant or it will be function of x. So that's why you'll be integrating with respect to x. So it will be dx. Okay. So once we have calculated this if, now we can write y into integrating factor equal to integral over q into integrating factor dx. This is the way how we can calculate this linear differential equation. Okay, now we have the second type. Second type we can have like this. This one is the first one. Second one we can have like this, dx by dy plus px equal to q. Okay, so as you can see here, we have been given dy by dx, like we are here we are differentiating this y with respect to x, while here we are doing dx by dy. So this p and q should be either function of x, function of y or constant. Okay, then a similar way you will be finding out here integrating factor. So we can write like this, e to the power integral over p. Now we are differentiating with respect to y, so that's why here we will be writing dy. And now at the place of y you will be writing like this, like x into, you will be writing x into integrating factor equal to integral over q into integrating factor. Oh, here we have done dx, you can see. Okay, so now you will be writing here dy. Why? Because here p and q are the function of y, or you can say those are the constant, and here you have been given dy. Okay, so once you have been given here dy, so you will be integrating here with respect to dy. Okay, so this is the two types of things. Okay, so now we can have one problem. So you can see. Okay, so we have been given one problem here, x dy by dx plus 2y equal to x square. So first what we can do, first we have to convert in the linear differential equation. Okay, so we will just divide by x on both sides. Okay, so we can get like this. Okay, fine. Now we'll compare with this one, dy by dx plus py equal to q. So from here we will be getting p, that is what, 2 by x, and q is x. Okay, now we'll have to calculate integrating factor. So you can write e to the power integral over p dy, p dx, not p dy, sorry, p dx. Here the function, this p and q are the function of x, that's why here we will be doing what, p dx. Okay, so you can write integrating factor, that will be what, e to the power, p is what, p is 2 by x. Okay, so 2 by x dx we can do, and here we will be getting what, e to the power 2 we can take out because this is constant. Okay, then integral over 1 by x dx. So this will be what, this will be e to the power 2 ln x, right? Because integration of 1 by dx will be 1 by x will be what, this will be ln x. Okay, so as we know, whenever you have been given this one like this 2 ln x, so we can write like this also, e to the power ln x square. This is log property. Okay, like this one you might be knowing, if you have been given log x to the power m, so this m also can be taken out. Okay, or if you have been given m here, so we can take on on this one x, okay, we can take as power. So if you look coming here, this one have been given ln, okay, so this ln can be written like this: log base e then x square. So you can see that here this base is equal to this one, okay. So whenever you have been given something like this, no, so just remove this log and all, and you can write x square, okay. So this is one log property actually. So this will be our integrating factor. Okay, so we got this one. Now we have to write like this one. If you will be remembering, y equal to y into integrating factor equal to integral over q into integrating factor dx, okay. So y, what is integrating factor here? That is x square. You write x square. What is q here? Just come here, see x is the q, no, x into then x square then dx. So we can write like y is x square. Here it will be x cube, no. So x cube, integration of x cube will be x to the power 4 by 4, and then one constant also will be coming. So this will be our answer. Like this we can solve, okay. So this one was the question that was in the form of dy by dx plus py equal to q, okay. But we can have one more question like this one: dx by dy plus px equal to q, okay. We'll see that one also. Okay, so let's suppose we have been given one more problem, that is what y dx minus x plus 2y square dy equal to 0. Now how can we solve this one? We can solve like this. Try to understand, okay. We can solve like this. We just write here y dx, and this all the thing you transfer in the right side. So we can write x plus 2y square then dy. Now you transfer this dy in the right side, it will left side, it will be dx by dy here, and then here we are remaining with x plus 2y square. Now we have to divide by y on both sides, so we will be getting dx by dy equal to x by y plus 2y. Now just take x by y in the left side, okay. I am trying to convert in the linear differential equation, okay. So it can be written like this. Now just compare with this one: dx by dy plus px, then we have q. If you will be comparing with this one, you can see that p is what? P is minus of 1 by 5 and q is 2y, okay. We can get this one, okay. Okay, so now we will calculating integrating factor. So integrating factor is what? E to the power integral over p. Here the p and q are the function of y, that's why here we will be writing dy, okay. And e is what? E to the power p is what? P is minus of 1 by y, so minus we just take out, then 1 by y, then here we will be writing dy, okay. Again it will be what? E to the power minus, and this will be ln y. So as I have told you, this minus you can take as common here, so it can be written as e to the power ln y to the power minus 1, okay. And again you can see that e and this ln can be written as log base e then y to the power minus 1, then these two are same, so that's why this can be written as y to the power minus 1, or it can be written as 1 by y, okay. So now this will be our integrating factor. So once we have calculated integrating factor, again we will be writing like this. So x into integrating factor, here in this case of we have to write like this, okay. So x into integrating factor equal to q into integrating factor into dx, right. Now we will just put the answer, okay, like values. So x into integrating factor is how much? That is 1 by y, and then q is how much? Let's see. Q is 2y, okay. So we'll put here 2y into integrating factor is 1 by y, then dx. This y will be cancelled by this one, and we will be getting how much? We will be getting x by y equal to, and this one 2 dx will be getting, so here it will be 2x plus c, okay. So yeah, so sorry, I have done any mistake, I think. Yeah, we are integrating with respect to y because we have been given dx by dy, okay. So whenever it will be coming dy here, and we are getting function of y to be this one p and q, so how will you be doing? Here we will be writing dy, okay. So I have done one mistake, sorry. So it will be dy, okay. Okay, so now the answer will be how much? 2y, okay. This will be our correct answer. Okay, so again I'm repeating, you just see this will be the first form. Okay, first form, this will be like first form, dy by dx plus py equal to q. So first, whatever question you will be given, you just have to compare with this linear equation and you have to find out the value of p and q. Once you have found out the value of p and q, then you have to find integrating factor that can be written as e to the power integral over p dx. Okay, so we are writing x here, dx here, because this differential equation whatever we have been given here, in denominator we have been given dx. Okay, you can think like this also, or you can think like this also, whatever p and q we have been given, either those will be function of x or that will be constant. Okay, so that's why here we are integrating with respect to x. So once you can find this one integrating factor, then you can write y into integrating factor equal to integral over q into integrating factor into dx. Okay, then again we have the second one we have dx by dy plus px equal to q. So again here you can see that this p and q should be the function of y, and these two should be constant. Okay, so integrating factor can be calculated as e to the power integral over p dy. Why? Because here you have been given dy. Okay, or we can see like this, like p and q whatever we will be getting, that will be the function of y, or that will be constant. Okay, that can be the constant, that's why I'm telling you, like no confusion should be there, and we have to see this denominator and accordingly we have to write here dy or dx. Okay, then x into integrating factor equal to integral over q into integrating factor equal to into dy. Okay, so we have to do like this, and then from here you can calculate the answer as we have seen in the examples. Okay, then we'll stop here. Thank you.